Right now, in the tropical Pacific Ocean, sea surface temperatures are climbing toward levels that could produce the strongest El Niño ever recorded by modern instruments. Forecasters at NOAA, the European Climate Agency, and the Australian Bureau of Meteorology have all independently arrived at the same conclusion over the past several months, that the event building through the back half of this year is on track to rival or even surpass anything measured since satellite monitoring began. That alone would be a significant story, but it becomes a genuinely alarming one once you understand what happened the last time an El Niño of this scale swept across the planet, because roughly 150 years ago, a climate event strikingly similar to the one now forming helped trigger what researchers have called the worst environmental disaster ever to befall humanity, a catastrophe that killed somewhere between 19 and 50 million people across 3 continents. Today, we are going to walk through exactly what happened in the 1870s, why scientists believe it could genuinely happen again, and why the conditions the world is walking into this time may, in some very specific ways, be even more precarious than they were back then. Before we get into it, if you want a clear, well-sourced breakdown of how climate events like this actually connect to human catastrophe rather than just headline-level fear, go ahead and subscribe now, because we track stories like this closely as new data and forecasts continue rolling in. Drop a comment below and let us know if you've ever lived through a major drought or an El Niño year yourself, because those first-hand experiences genuinely help other people understand what these forecasts translate to on the ground. And if this breakdown helps you make sense of a story that's easy to either dismiss or catastrophize, sharing it helps more people get the full, grounded picture. No dramatizing here, just the facts and the research. Let's get into it. To understand why scientists are watching the current forecast so closely, you first need to understand what happened between 1876 and 1878, because it remains, even today, the deadliest environmental disaster in recorded history. The trigger was an El Niño event so powerful that researchers who studied it decades later concluded it may have been the strongest ever to occur, at least among those that left behind enough physical and historical evidence to reconstruct with confidence. Normally, trade winds blow steadily from east to west across the tropical Pacific, piling up warm water near Asia and Australia, while allowing cooler, nutrient-rich water to rise along the coast of South America. During an El Niño, those trade winds weaken or even reverse, and the warm water that would normally sit in the western Pacific sloshes back eastward, fundamentally rearranging where heat and moisture end up getting deposited across the planet. The atmosphere responds to that shift by rerouting entire rainfall systems, and the monsoons that hundreds of millions of people across Asia depended on for their harvests essentially failed to arrive on schedule, in some regions for 2 consecutive years running. The human toll of that failure was almost incomprehensible in scale. In India, what became known as the Great Famine of 1876 to 1878 was triggered by an intense drought that caused catastrophic crop failure across the Deccan Plateau, eventually affecting an area of roughly 670,000 square kilometers, and causing distress to a population totaling nearly 59 million people. Careful demographic reconstructions place excess mortality in India from this single famine somewhere between 5.5 and nearly 10 million deaths, with researchers converging on a figure around 8 million as the most defensible estimate. In northern China, a nearly simultaneous catastrophe, now referred to as the Northern Chinese Famine, killed somewhere between 9.5 and 13 million people across the provinces of Shanxi, Zhili, Henan, and Shandong, with Shaanxi province alone accounting for an estimated 5.5 million of those deaths. Northeastern Brazil suffered its own version of the disaster, a prolonged drought known as the Grande Seca, which killed roughly 500,000 people in a region that had never before experienced anything close to that scale of climate-driven mortality. Add these regional catastrophes together, along with smaller but still devastating famines that struck other parts of Africa and Asia during the same window, and researchers estimate the combined global death toll landed somewhere between 19 and 50 million people, representing something in the range of 3 to 4% of the entire population of the planet at the time. A team of researchers writing in the Journal of Climate in 2018 described the event in blunt terms, calling it arguably the worst environmental disaster to ever befall humanity. And climatologist Deepti Singh, who has studied the event extensively, has stated plainly that no deadlier environmental disaster has occurred since. What made this particular El Niño so uniquely catastrophic wasn't simply its raw strength in the Pacific. Researchers studying the event have identified it as part of what amounted to a rare and devastating convergence of multiple climate systems acting in the same direction at once. Alongside the record-strength El Niño, the Indian Ocean experienced an unusually extreme positive phase of what's called the Indian Ocean Dipole, a separate climate pattern that involves a temperature seesaw between the eastern and western halves of the Indian Ocean. In 1877, researchers have found that the thermal contrast between those two halves of the ocean was the strongest ever recorded before or since, and that extreme dipole likely amplified drought conditions not just across South Asia, but as far away as Australia and southern Africa. At the same time, the North Atlantic Ocean was experiencing an unusual warming episode of its own, adding yet another layer of disruption to global atmospheric circulation patterns during the exact same 2-year window. Researchers describe this as a synchronized, near-simultaneous failure across multiple independent parts of the global climate system, monsoons vanishing over India, rivers running dry across northern China, the arid interior of Brazil turning to dust, and harvests withering across parts of Africa, essentially all at once, driven by a stack of climate anomalies that rarely align this precisely with one another. It would be a mistake, though, to treat this purely as a story about climate alone, because the researchers who have studied the 1876 to 1878 catastrophe most closely are consistent in stressing that drought was the trigger, not the sole cause of the death toll that followed. Political and economic decisions played a central, and in many cases decisive, role in determining just how deadly the climate shock actually became. In colonial India specifically, the disaster was made dramatically worse by the systematic neglect, and in some cases outright destruction of traditional water and grain storage systems that communities had relied on for generations to buffer against exactly this kind of shock. Meanwhile, the colonial government continued regular grain exports throughout the famine, and the viceroy at the time, Lord Lytton, oversaw the export of a record 6.4 million hundredweight of wheat to England, even as millions of people starved within the same colonial territory. Relief efforts, where they existed at all, were often designed around minimizing government expenditure rather than genuinely addressing starvation, with famine relief workers in some programs receiving as little as 450 grams of grain plus a single anna per day in exchange for hard manual labor performed without shade or rest. Florence Nightingale, reacting to reports coming out of India at the time, wrote that the more one heard about the famine, the more one felt that no other record of human suffering and destruction the world had known could compare to it. In China, the drought interacted with a country already destabilized by the aftermath of the Opium Wars and the Taiping Rebellion, conditions that left the state far less capable of mounting an effective response than it might otherwise have been. The consistent lesson researchers draw from comparing these regions is that the same magnitude of climate shock produced wildly different death tolls depending entirely on the strength or weakness of the human and institutional systems standing in its way. This wasn't even a single isolated tragedy that resolved itself and faded into history. A second severe El Niño struck again in 1896 and 1897, triggering another devastating round of famines across many of the same regions that had barely begun recovering from the 1870s catastrophe. Before those communities could fully rebuild, a third, somewhat less severe El Niño arrived in 1899, triggering yet another round of crisis. Demographers studying this repeating pattern have coined the term bang-bang famines to describe exactly this kind of sequence, where one climate disaster strikes a population that hasn't yet recovered from the previous one, compounding the damage in ways that a single isolated event never could. It was ultimately in the wake of these repeated 19th century catastrophes that colonial authorities in India were forced to develop what became known as famine codes, formal systems that codified government responsibility for relief efforts, an early and painful lesson in disaster preparedness that emerged directly out of this specific chain of climate-driven catastrophes. It's worth pausing to actually explain how an ocean warming event thousands of miles away in the Pacific can end up starving people on the other side of the planet in India and China, because the mechanism itself is genuinely fascinating, and it's central to understanding why these events reach so far beyond the Pacific basin itself. Under ordinary conditions, steady easterly trade winds push warm surface water westward across the Pacific, which keeps a deep pool of warm water parked near Indonesia and northern Australia. That warm pool acts as a kind of engine for rising air, which in turn helps power monsoon systems and rainfall patterns across a huge swath of South and Southeast Asia. When an El Niño develops and those trade winds weaken or reverse, that warm water pool shifts thousands of miles eastward toward South America, and the entire atmospheric engine that used to sit over Asia effectively relocates with it. The rising air, cloud formation, and resulting rainfall move with the warm water, which means the monsoon systems that India and China depend on for their harvests lose the fuel that normally powers them. Meanwhile, the redistributed heat and moisture triggers unusual flooding in parts of South America and the southern United States, even as Asia and parts of Africa dry out. This entire chain reaction, scientists call it a teleconnection, is exactly why a warming event confined to a relatively narrow strip of the equatorial Pacific Ocean can simultaneously trigger drought on one side of the world and flooding on the other. And it's precisely this teleconnection effect that made the 1876 to 1878 catastrophe a truly global event rather than a regional one. Now here is where the story becomes genuinely relevant to what's happening in the world right now, rather than something confined entirely to the history books. A 2020 study examining the 1877 to 1878 El Niño in detail found that, statistically, it was directly comparable in strength to the handful of so-called Super El Niño events that have occurred since modern satellite and ocean monitoring instruments began tracking these patterns, specifically the events of 1982 and 1983, 1997 and 1998, and 2015 and 2016. That finding matters enormously because it means the 1870s catastrophe wasn't some unique, one-off fluke of 19th century climate variability that modern science has since made impossible. It was, instead, an example of a genuinely recurring category of extreme climate event, one capable of arising, again under the right combination of ocean and atmospheric conditions, entirely independent of whatever technological or scientific progress humanity has made in the intervening century and a half. Which brings us directly to what is happening in the Pacific Ocean right now. As of early April this year, the El Niño Southern Oscillation System sat in a neutral phase following the end of the 2025 to 2026 La Niña, with near-average sea surface temperatures across the central and eastern equatorial Pacific, but rising subsurface heat content that immediately caught the attention of climate monitoring centers around the world. By mid-May, the World Meteorological Organization's global producing centers had shifted their forecasts sharply, placing the probability of El Niño conditions developing by the June through August window at 80%, with that probability climbing to somewhere near or above 90% for the following several months through the end of the year. NOAA's Climate Prediction Center made it official on June 11th, upgrading its outlook from an El Niño watch to a full El Niño advisory, meaning El Niño conditions were no longer simply forecast. They were confirmed as actively present and strengthening. By early July, the sea surface temperature anomaly in the key Niño 3 for monitoring region sat at approximately positive 0.7 degrees Celsius and climbing, fed by a substantial pool of warm water building beneath the ocean's surface that forecasters read as a strong signal of continued intensification through the remainder of the year. The forecasts released since then have consistently trended in one direction, toward greater strength rather than less. Multiple major forecasting bodies now place the probability of a very strong so-called Super El Niño peaking sometime between November of this year and January of next year at around 63%, an unusually high level of confidence for a forecast issued this many months in advance. Pooling together results from the full range of major international climate models, the consensus projection for the 2026 to 2027 event now points toward a peak roughly 3.6 degrees Celsius warmer than average in the key Pacific monitoring region, a number that, if it verifies, would place this event ahead of every previous El Niño on record, including the historically powerful events of 1997 to 1998 and 2015 to 2016. Meteorologists tracking the string of forecast updates released since the start of the year have noted a consistent pattern, that each successive model run has nudged the projected peak intensity higher rather than lower, a trend that tends to make forecasters increasingly confident rather than increasingly skeptical about where the event is actually headed. It's worth noting that the World Meteorological Organization itself does not officially use the term Super El Niño, since it isn't part of the organization's standardized operational classification system, but the underlying sea surface temperature thresholds that meteorologists informally use to apply that label are exactly what current forecasts suggest this event is on track to reach or exceed. So why might this event, even if it doesn't ultimately surpass the raw strength of the 1870s catastrophe, still end up mattering more, or causing damage that rivals or complicates comparisons with history's worst climate disaster? The answer comes down to a combination of factors that simply didn't exist a century and a half ago, some of which make today's world considerably more resilient than it was in the 1870s, and others that make it considerably more exposed. Start with the most fundamental difference, the baseline temperature of the planet itself. The El Niño of 1877 arrived on top of a global climate that, whatever its regional extremes, was not carrying anywhere close to the accumulated background warming the planet carries today. This 2026 to 2027 event is instead forming on top of a planet that has already pushed well past the 1.5 degrees Celsius warming threshold in individual record years, meaning that whatever additional heat an extremely strong El Niño dumps into the atmosphere gets added on top of a baseline that is already historically elevated, rather than on top of a comparatively stable 19th century climate. Climate scientists tracking this dynamic have been explicit that our planet's long-term human-driven warming trend is almost certain to push into genuinely new record territory as this El Niño matures, with a real possibility that global average temperatures could reach unprecedented levels either later this year or during the course of 2027, purely as a consequence of this event's oceanic heat release layering directly on top of decades of accumulated greenhouse warming. The second major difference lies in who and how many people now stand directly in the path of the disruption this event is expected to cause. The global population in the 1870s stood at somewhere around 1.5 billion people. Today, it exceeds 8 billion, meaning that even a proportionally smaller climate shock now has the potential to directly affect a vastly larger absolute number of human beings, many of them concentrated in exactly the kinds of drought-vulnerable agricultural regions that suffered the worst in the 1870s. Researchers and humanitarian organizations tracking the current forecast have been explicit about where the sharpest risks are concentrated this time around, and the list reads uncomfortably close to the geography of the 19th century catastrophe. The Sahel, Southern Africa, South and Southeast Asia, and Central America's dry corridor are all currently flagged as facing more than a 50% chance of significant drought over the coming months, with many of these same regions having already been hit hard during the more recent El Niño events of 2015 to 2016 and 2023 to 2024. The Joint Research Center of the European Commission described the emerging pattern bluntly in a recent assessment, warning that the 2026 to 2027 El Niño will layer directly on top of existing displacement, ongoing armed conflicts, and food insecurity already affecting millions of people, raising the genuine risk of forcing already vulnerable populations to flee their homes for a second or even third time in East Africa, Central Africa, the Central American Dry Corridor, and parts of South and Southeast Asia. Specific national situations already illustrate just how directly this looming event threatens to intersect with existing humanitarian crises. In Myanmar, food security has already deteriorated sharply due to rising prices even before the El Niño's worst effects have fully arrived, with roughly 12.5 million people facing crisis-level food insecurity as of May, a figure humanitarian agencies expect could climb past 20 million by the middle of the year as drought conditions compound an already fragile situation. In Haiti, gang violence, economic collapse, high inflation, and worsening climate conditions have already pushed around 6 million people, more than half the country's entire population, toward crisis-level food insecurity, and forecasters expect the coming drought risk in the region to deepen an already catastrophic humanitarian emergency, rather than simply adding a new, separate problem on top of it. In the Philippines, authorities have already warned that 15 separate provinces face a real risk of severe El Niño-induced drought in the coming months. Cameroon's Adamawa and far north regions are being flagged for severe drought risk that threatens harvests, agricultural incomes, and the nutritional status of already vulnerable populations, while Madagascar faces the uncomfortable combination of drought in its south alongside an increased cyclone risk along its eastern coast during the very same stretch of months. The UN's Food and Agriculture Organization and World Food Program have jointly warned that the international community currently has only a narrow window in which to act before crisis thresholds are actually crossed in many of these locations, with WFP's leadership describing this as a genuine test of whether the world can prevent another major food crisis before it fully materializes, rather than simply responding to one after the fact. There is, however, a meaningfully more hopeful side to this comparison, and it would be dishonest to lay out the risks here without giving equal weight to what has genuinely changed for the better since the 1870s. The most important difference between now and then isn't really about the strength of the El Niño itself, it's about the systems humanity has built specifically to detect, anticipate, and respond to exactly this kind of climate shock before it turns into mass starvation. El Niño is now recognized as one of the most predictable major climate phenomena on the planet, meaning governments and humanitarian organizations today have months, sometimes close to a full year, of advance warning before an event like this actually peaks, a luxury 19th century societies simply did not have. Modern agricultural monitoring systems can track crop stress and drought risk across entire continents in near real time. Global food trade networks, whatever their flaws, allow grain and other staples to move relatively quickly from surplus regions to deficit regions in ways that were logistically far more difficult a century and a half ago. Organizations like FAO and WFP have already begun rolling out anticipatory action programs specifically tied to this event, including cash assistance, distribution of drought and flood-resistant seed varieties, livestock protection measures, and early warning advisories tailored to local conditions, with systems already in place to support roughly 1.2 million people expected to be directly affected, and plans to rapidly expand that support to reach an additional 7.6 million people across 22 priority countries, if additional financing becomes available in time. As FAO's Deputy Director General Beth Bechtel put it, experience has repeatedly demonstrated that acting before crisis thresholds are actually reached is both more effective and considerably less costly than waiting to mount an emergency response once disaster has already unfolded. The risks tied to this event also extend well beyond agriculture and human food security, reaching into ecosystems that hundreds of millions of people depend on in less direct but still critical ways. Coral reefs are especially vulnerable to the kind of intense ocean warming a Super El Niño produces, and the two most powerful recent events in 1997 and 1998, and again in 2015 and 2016, were both associated with major global coral bleaching episodes that devastated reef systems supporting fisheries, tourism economies, and natural coastal protection against storms across dozens of countries. Warmer, drier conditions in regions like South America also tend to lower the threshold for forest fires to ignite and spread, damage that in some cases takes decades of forest regrowth to fully recover from, while simultaneously releasing enormous additional quantities of stored carbon back into the atmosphere, in a feedback loop that makes the underlying warming problem measurably worse. The World Resources Institute, in a recent assessment of what a genuine Super El Niño could mean this cycle, described the potential outcome as stronger and more persistent impacts, extending well beyond agriculture, touching some of the world's most productive fishing grounds and the livelihoods of coastal communities that depend on them, layered on top of increased risk from droughts, floods, cyclones, and extreme heat occurring more or less simultaneously across different parts of the globe. Pulling all of this together, the honest, carefully calibrated answer to whether this coming El Niño could genuinely rival or exceed the catastrophe of the 1870s is that it depends far less on the raw strength of the ocean warming itself, and far more on how effectively the modern world manages to translate its considerably more advanced early warning systems into actual, timely, well-funded action on the ground. The physical climate event now developing in the Pacific is, by the numbers currently being forecast, plausibly the strongest of its kind ever measured by modern instruments, arriving on top of a planet that is already running hotter than at any point in recorded history and carrying more than 5 times the human population it did during the last comparable event. That combination alone is enough to justify the level of attention this forecast has been receiving from climate scientists and humanitarian planners over the past several months. But unlike in the 1870s, when drought turned into mass starvation largely because the political and economic systems of the era either failed to respond or, in some cases, actively worsened the crisis through policies that prioritize profit and control over human survival. Today's response infrastructure, however imperfect and underfunded it remains in practice, genuinely exists and is already actively mobilizing months ahead of the event's expected peak. As Vimal Mishra of the Indian Institute of Technology Gandhinagar put it, reflecting on the lessons the Great Famine still holds for the present day, understanding what happened in the 1870s gives us a genuine idea of how to be better prepared this time, rather than simply a reason to assume history is doomed to repeat itself in exactly the same form. What ultimately determines whether this cycle becomes a genuine humanitarian catastrophe or a serious but manageable global stress test will most likely come down to the same variable that determined the outcome 150 years ago. Not the strength of the climate anomaly itself, but the strength, funding, and political will behind the human response to it. The regions facing the highest risk right now, from Myanmar to Haiti to the Sahel to Central America's dry corridor, are almost all places where conflict, economic instability, or chronic underinvestment in resilience infrastructure has already left populations with less capacity to absorb an additional shock, which is exactly the same pattern researchers identified as the deciding factor in the 1870s. The climate science behind El Niño forecasting has advanced enormously since the 19th century, but the fundamental lesson from history's deadliest environmental disaster hasn't really changed at all, that a powerful climate shock becomes a genuine mass catastrophe, not simply because the drought itself was severe, but because of what happens, or fails to happen, in the response that follows it. We will keep tracking this event closely as it continues to build toward its expected peak later this year and into early 2027, including how the humanitarian response actually unfolds across the regions currently flagged as highest risk. If you want to stay ahead of how this develops rather than catching it only once the worst headlines start arriving, go ahead and subscribe now and drop a comment telling us which region you think deserves the most attention as this event intensifies, because that's genuinely one of the more important open questions humanitarian planners are wrestling with right now. Thank you for watching all the way through, and we will see you in the next one.